Today's project is custom designed remote control window operators. These are vent windows that are way up at the top of my game room roof. There's two on that side and two up here. I still have to install the one on the right. But where I live in California, I maybe need air conditioning for 2 or 3 days out of the year, and that's it. So I wasn't going to put in air conditioning in this big game room. However, when all of the games are running, it does get real warm in here. So my idea was I'd put in these windows, and I need to be able to open them. I'm obviously not going to climb all the way up there to open the windows, but then turn fans on and I could just suck out the hot air, replace it with cool air. Especially in the evening, cool air will be coming in through these windows. So that's my solution, but need a way to open those windows and close them way up high. So designed a circuit, which I'll show you in a minute, but they're all controlled here by this panel. And so I have 4 windows, and what I can do is select the windows that I want to operate. I'll do windows 3 and 4, which are those ones over there on the opposite side of the game room. And then I can open and close the ones I select. So I'll hit the open button. And the windows start opening. Now you hear that both windows have stopped. They are completely open, yet I am still pushing on the button. I'll let go now. My idea here was that these motors will all work at slightly different speeds, and when a window gets fully opened or fully closed, I don't want to keep applying electricity to the motor, because that'll keep trying to run it and it'll be binding and burn out the motor or strip the gears inside. So I wanted to design a circuit that would monitor the speed of the motor, and as soon as it started to slow down, because I was getting close to the end of opening or closing, when the circuit senses that the motor is slowing down or stops, then it instantly, within a few milliseconds, shuts off power to that motor so that they can all work independently and get open or closed at their own time. And I can open or close just one window at a time, or do all 4 if I want. But now that the windows are open, come down here, and these are individual switches. So I got windows 3 and 4, so there's fans 3 and 4. I'll turn them on, and we're now venting out the game room. If I shut them off, then they eventually slow down and stop. And now with the fan off, I can close the windows. And here again, when both windows are closed, the motor shut off, and I'm good to go. This is page 3 of the schematic diagrams for my home automation system. Sheets 1 and 2 have alarm contacts and motion detectors, everything else for the home automation system. On this sheet I have my HVAC control with zone dampers, 1 for each story. I have an automated fish tank that does automatic water changes underground, and these are level sensors for the water level. And I've got a 3-way flow control valve, motorized head, sprinkler valves that fill the tank back up, So all of that I could do its own separate video on, but what's on here that's relevant to this project is the schematic for my motor protection and automatic cutoff. I have 12 volts coming in here, and depending on if I want to open or close the windows, 12 volts come in, but if I open, the two switches go up and connect plus and minus in one direction through to the motor controller. If I go closed, then this switch reverses the polarity of plus and minus and sends it on. And so whether the electricity is going in one polarity or opposite, then that will cause the motor to spin one way or the other. But I need to take that voltage, whether it's positive or negative 12 volts, and rectify it and keep it all in a positive 12 volts across here to supply the electronics in the 555 timer. And so this timer, if you know electronics, 555, very versatile, can be used for many different things, like putting out square waves or different frequencies. That's called an astable multivibrator. This particular design is what's called a one-shot monostable timer. So what happens is, as the motor is spinning, there are pulses coming out, square wave pulses coming out of a Hall effect sensor. This is mounted, or the sensor is mounted on the back of the motor, and so as long as the motor is spinning, this is putting out square wave pulses. That comes down to here at a certain frequency, and going through this circuit with a diode protection, those pulses keep hitting this transistor and causing it to turn on. So it's rapidly turning on, and what that does is each time it turns on, it shorts out this capacitor and keeps it drained, so that keeps a low level on pins 6 and 7. Now once the motor starts to slow down and these square wave pulses expand out, then this transistor is not getting hit quite as often, not turning on as rapidly. It allows this capacitor to start charging up. And if you know your 555 timer, once we get up to a certain voltage, then that tells the output to drop low. All this time the output has been high, energizing this relay, closing the contact so the voltage could get through to the motor. But once this is allowed to time out, and that happens as soon as we start to slow down, then pin 3, the output goes low and the relay de-energizes, and then the motor is cut off. Even if there's still voltage coming in, because I continue to hold the button for open and close, we de-energize this relay. And so right here, these two components, that causes pin 2, the trigger pin, to start the timing cycle when voltage first rushes in and powers this up. These two components start a negative going pulse that then charges and goes high, but that negative pulse is needed to start this thing in its initial timing cycle. So again, the purpose of this whole circuit is to protect and shut off the motor as it starts to slow down when the window reaches fully open or fully closed, so that it's not sitting there binding and burning up the motor or stripping the gears in the gear head. Here's the inside of the box, where I have the 12 volts coming in through the side, and then it goes out to the bridge rectifier. I've got the 555 timer over here and the little relay here, and this is where the encoder and motor come in and then go onto that terminal strip there, or that pin plug-in header, and then this is the electronics that interpret that and sends it on to the 555 timer. Some details on this motor, and the thing here on the end is a spline type socket, Craftsman brand, that I adapted and put onto the motor. So the spline teeth in there are the right pattern to mate up with the window crank. When I remove the handle, That goes in its place. Here's the unit installed on the window. I've got the fan there, plugged into AC. This is actually the 12 volts coming in, even though it's Romex. And then I have it marked which side's black and white. The two lights work in this fashion. If the fuse inside were to blow when I would go to open the window, the red light would come on telling me the fuse is blown, so I have a motor problem or electronics problem. But if the motor operates and everything is working, then this green light will be on for as long as the motor's working. And so the motor here is spring-loaded, and that spline, this comes on and off easily in case I ever want to crank the window by hand. But that just goes over it, locks on to do its job, and here's the handle that I removed that's sitting up here, right there, in case I ever need to come up here and crank it by hand.
For more information, visit GameRoomRepair.com.